Hello, I'm David Reed, Extension Tobacco Agronomist at the Virginia Tech Southern Piedmont Center. I thank you for joining us on our virtual update of our tobacco research program. This presentation will address the application of some potential new technologies to tobacco research and production. Some of these new technologies include the development of a prototype robotic tobacco transplanter, real-time soil moisture monitoring probes, multispectral UAV imaging of tobacco, LiDAR UAV imaging to estimate tobacco yield, hyperspectral imaging of tobacco, and then finally real-time estimation of tobacco crop health using the OptiRx system. Here's a couple of photographs of our prototype tobacco transplanter, and unfortunately the pandemic has really impacted what we could do in development of this. This is being worked on with a group of mechanical engineering students on our main campus, and travel restrictions really limited how much interaction we could have on a one-on-one basis. But the guys really worked on this. You can see what they have been able to do, working on it in their shop there near Blacksburg. We have sent trays of plants there throughout the year for them to do some testing in their shop. However, we have not been able to do any field testing of this. We currently have some plants growing in the greenhouse, and in about a month, we hope to start doing some actual field testing of this unit. But the left photograph shows the commercial Ferrari tobacco transplanter. That's what you would buy off the shelf, and then that's mounted to the toolbar. And then the aluminum and the wiring that you see in that photograph, that's the robotic system that the group of students have been working on to make this a robotic transplanter. Go to the second shot there on the right, and that shows a black plastic tray at the top of that photograph and how it fits into the system. And the way the system will work, it will remove one row of cells from the tray at a time, sort through those cells to determine which plants are usable and which ones are not. The usable plants will be loaded into a cassette that moves through the system, and you can see that again back in the left photograph where it's making the turn. You see the black cassette that would be loaded with plants, and then on the underside, after it makes that turn, the transplants would fall into the individual cups of the tobacco transplanter. So again, I'm very excited about the work that has been done on this, and we're just waiting to try to get some field testing done. That's the next step. I've been interested in measuring soil moisture for a number of years, and we've been involved with this for quite some time, and my goal has been to try to develop better, more quantitative management programs for irrigation of tobacco and try to just make things more efficient and try to optimize our tobacco production. So the system that we're currently using is the Syntec drill and drop soil moisture probe, and you see that in the photograph. All we see of the probe is the blue cap at the top of the probe. That really contrasts to what we've been doing in the past with much larger probes. Some of them have had solar panels, we had cables going through the field, and all of that has been problematic in the tobacco field because it gets in the way of our cultivations. Other equipment passes through the field, harvesting of the tobacco. All of this equipment has been in the way. So this probe is very attractive for using in tobacco since it's so compact and easy to use. The probe measures volumetric soil moisture and ion content as well as soil temperatures. And this probe that we're using has 9 sensors at an interval of every 10 inches, or 10 centimeters or 2.5 inches. And so we're measuring soil moisture from 5 to 85 centimeters or 2 to 33 inches in the soil profile. Readings are made every 30 minutes, and then the data is stored. And then we have a Bluetooth link where we can go into the field with an iPhone or an iPad, upload the data, and then that's transferred on up to the web-based software package. And what we're using there is Irmax Live software. And this is an example of what that software will give us. We can look at a lot of different data points and look at a lot of different graphs with this software. I've picked two for this example. The bottom graph is just the summation of all the 9 individual soil moisture probes. So it gives us the sum of the total soil moisture in the profile over time. And we can see the pattern. That graph, the blue at the top, that's our full point. That's a point where I have chosen that will be saturated with moisture in the profile. And then at the bottom, there's a line, a refill point. That's the point that I've chosen that I don't want the soil moisture to fall below. So we're trying to keep the moisture between the full point and the refill point. You don't see it on this graph, but then we'll have another line below that that'll be a stress line. And I'll show you that on another graph. But that's the point where the tobacco will become stressed due to lack of soil moisture. You can see the 4 arrows that I've added to the graph. That's showing 4 irrigation events. And then you can see that we got a response in soil moisture there, looking at the sum of the different sensors. And then to the far right of that bottom graph, we can see we got a big increase there at the 3rd of August, and that was Hurricane Aisha that came through. We got over 3 inches of rain in a short period of time. And you can see the response in soil moisture. It pushed us up to the refill, or excuse me, the full line. The top graph is the soil moisture of the individual sensors. So we're looking at 9 different depths in the soil profile and the moisture at each of those. I've added an arrow there, the red and blue arrow. That's, you see those ovals below that. That is an indication of root activity. And so the data, or the software, is analyzing the data and looking at root activity and what depths in the soil profile are the roots removing soil moisture. And the length of that oval will indicate the length of removal. And then the height of that will actually be an estimation of the quantity of moisture that was removed over that time period. So early on, before the storm, you can see that our soil moisture removal in this irrigation treatment, where we're irrigating quite regularly, we were removing moisture from 15 to 45 centimeters deep, or 6 to 8 inches deep in the soil profile. Here we're looking at the soil moisture data from the treatment where we were not irrigating. So this tobacco has not been irrigated. It's gone through quite a stressful time period. And so the bottom graph, again, is the summation. We can see that a lot of that is in the pink area. So that's below our stress line. And in fact, this plot was actually being stressed for about 3 weeks below the stress line. So there's not a lot of soil moisture removal occurring. There's not a lot of water in the profile to remove. And then we see the big increase in soil moisture there with the 3rd of August. Looking at the graph above of the individual sensors, we can see the root activity here. Instead of removing moisture 6 to 18 inches, we're removing a lesser amount of water, but we're removing that deeper in the profile, 12 to 22 inches deep. And that's before the storm that occurred on the 3rd of August. After the 3rd, you can see those colored ovals have moved up into the profile, and we're removing water from the soil profile 6 to 45 centimeters deep, or 2 to 18 inches deep. So, the software can just help us to visualize very well what's going on in the soil profile. This is the same probe, but I've added a graph to the top there that's looking at the ion content. We call that volumetric ion content. And we're, that solid line there, that's at 5 centimeters deep. So, the ions that it's recording or measuring in the profile, these are very close to the surface. I think that's showing us that it's dry, water has evaporated from the soil, and in that process it's accumulating salts very near the soil surface. So then look to the right. After we had our rainfall the 3rd and 4th of August, that black line falls, so the ions have been washed from the shallow depths in the profile to deeper depths in the profile, and it's more uniform. These ions are more uniformly distributed at those deeper depths in the soil profile. And I think this is evidence for what we frequently see after a dry period. We'll go through a dry period. Tobacco can begin to yellow and lighten in color a little bit. If we get a significant rainfall and it greens back within a day or two, and I think this is showing us exactly what's going on there. We're moving the ions or the fertilizer away from the surface, deeper in the profile, where the plant roots can take it up, and then the crop responds. The soil moisture data is pretty easy to interpret. We're still trying to interpret some of the ion content data, and so we're working on a collaborative project with 4 other universities across the United States to develop some calibration curves for that volumetric ion content data, and trying to match it to individual soil types like we would, so I'm working on soils that are specific to Southside Virginia and specific to tobacco. And what we're doing, we've gone back in the row where we've installed our Syntec probes, and the adjacent plant will install what's called a solute sampler. It's a gypsum bulb that's located it's placed 6 inches deep in the soil profile. It has a tube attached to it. We pull a vacuum on that, so then over time we can remove the soil solution in the profile at that depth, and then we can analyze it. We can look at the total amount of ions and compare that to our volumetric ion content reading that we're getting from the probe, and we can analyze that solution for nitrogen and potash in particular, or anything else that we may have interest in. So the goal of this project is to develop calibration curves specific for some of our tobacco soils. So I think for me, the Syntec soil moisture probe we're looking at has been a very useful research tool. Hope we can try to develop better management practices for our irrigation. I know for me at least, it's providing some insight into the nature of tobacco rooting and how the plant itself responds to soil moisture. It's certainly going to provide some insight into fertilizer movement in the soil profile. We always have questions early in the growing season, following a heavy rain early in the season. How is our fertilizer leached in the profile? Has it leached out of the profile, or has it simply moved deeper in the profile? So I think this system will help us develop answers to those questions. And in fact, I can see in the future where a grower might use these probes himself to better quantify what's happening with fertilizer on their farm. And eventually the goal is to use these data and this technology to develop more critical management information that allow us to better optimize our yield of tobacco. That's our goal, is to produce as high a yield as possible of high quality tobacco. And we're already incorporating this technology into some trials that we have underway now to look at irrigation programs and soil moisture management programs and fertilization programs to address how to produce tobacco with specific leaf chemistry traits. And there we're specifically talking about reducing sugars and nicotine. This technology I'm confident it's going to help us to develop some better management programs to address that. I'll now introduce you to Caleb Hinkle. He's a master's student from Lunenburg County, has a lot of interest in tobacco production, and his actual master's research program is addressing production practices to produce low nicotine flue-cured tobacco. However, as part of this, he's been looking at a lot of other technologies or new technologies that we can try to adapt to tobacco research and production. So he's going to talk with you about several of these, and some of it is how he's incorporating it into his research program.
Thank you, Dr. Reed. So multispectral UAV imaging, LiDAR UAV imaging, hyperspectral imaging, and real-time crop health are just a few of the main precision ag techniques that we're studying here at the Southern Piedmont. Multispectral imaging captures data within a specific set of ranges in the electromagnetic spectrum. And we collect this data so that we can compare it across multiple treatments and varieties using multiple indices, such as NDVI, ENDVI, NDRE, and many more. The goal is to identify the variations in vegetative health throughout a field that could possibly be correlated to multiple different factors of production. Along with being able to calculate multiple vegetation indices using this data, our post-processing software, Precision Analytics, gives us plant counts and plant areas for your crop field. This data can be very useful when trying to understand how areas are being affected in your field and which areas of the field need most attention. Light detection and ranging, also known as LiDAR, is a method of remote sensing that uses a pulsating laser which measures the distance of an object in its relation to the Earth. We collect this data, also known as point clouds, to analyze the volumetric content of above ground biomass in a crop field. Our goal is to be able to predict yield using this UAV LiDAR unit after much sufficient post-processing and ground proofing data. The purpose of these volumetric measurements is to get an idea of the volume of above ground biomass that is out there in the field. We can then compare this to the yield that the grower receives to help us better understand how to predict yield in the field using only the drone. Hyperspectral imaging is another form of imaging. It captures a large range of the electromagnetic spectrum. So our equipment, we collect 2,150 different bands in the electromagnetic spectrum. We use this data to develop machine learning algorithms that we can then use to differentiate between varieties and even nicotine levels. Our goal for this technology is to eventually image tobacco and provide an instant feedback on the current nicotine levels in the plant. Our real-time crop health data is recorded using an OptiRx system by Ag Leader. This technology uses multispectral sensors to calculate both NDVI and NDRE real-time as we move through the field. This technology is typically mounted on sprayers. So ours mounted on the sprayer. We collect data every time we make an application through the field. This gives us a better insight into the crop health across our different treatments and studies in our research plots. And this technology could potentially become a cheaper, easier alternative to drone integration in a farm operation. There's also potential to use these variable rate applications of fertilizers and CPAs using this technology. This is the raw data that we retrieve from the sensors. This provides us with plant health measurement values that we can then interpret to be specific fertilizer rates required by the plants themselves across the field. This data, after much post-processing, we can put back into our fertilizer applicators or our sprayers and apply variable rate across the field as needed. With the continued research of these technologies, we hope to develop more specific applications in the agriculture industry for both production and research. Thank you.
Thank you, Caleb, for that presentation. Please, if anybody has a question about anything that we've talked about or any comments, you want to follow up on any of what we've discussed, please do not hesitate to contact me at the research station. Thank you.